Okay, so good evening, everyone. So, yeah, so today's agenda of the session will be like first we'll introduce the course instructor, then we'll see the what will be the learning objective of this course, then we'll discuss the overall syllabus of the embedded C programming, then maybe we'll discuss the like practice programming assignment of week one. Then after that, if you have any doubt, then you can ask. Okay, so let me share my screen. So my screen is visible, right? Hello.
Yes, sir.
Yeah. So for this embedded C programming, course instructor will be first like Arup Kumar Chattopadhyay. So he has done PhD from CIT Cockroach. Then Atul Pratap Singh. Atul sir, maybe you can introduce yourself.
Yeah, hi everyone. So I am Atul Pratap Singh. I hope you know because we have already done C programming course. So I think team is also same. So this Levin Nectar, and me, Arup sir is also Arup sir was also there in the C programming, but he haven't taken any session. But he was also the part of the team C programming team. Okay, so this time we are also handling this embedded C programming. So we will, yeah, definitely we will meet in the session during the course. Yeah, Subhendu, thanks.
Yeah, thanks Atul sir. Then Levin Nectars. So maybe he'll be join. Levin, are you there? Okay, then
No,
myself.
Levin is not.
Okay, then he maybe join. Maybe just messaged. Okay. And myself Subhendu Gorai. So I have done BTech from Haldia Institute of Technology. Then after that I have joined here and I'm mostly work on the system level like DBMS, then computer system design in the DS, the operating system, then system command in 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 C, yes, that Linux programming. Then after that embedded C, right? Okay, then and living actor, so as he's also a course instructor of a living actor, he's, I think you know me, you know living that from C programming, right? Okay, so okay, the 1 minute. Okay, then after that what will be the learning objective of this course, right? So first is will be like embedded C program, so you can debug, you can develop proficiency writing, debugging, and optimize embedded C course, and will be focusing on the memory management, then a bit manipulation and low level hardware interfacing, right? Then after that, microcontroller architecture and application. So you can understand the basic microcontroller architecture, then including CPU, memory, and I/O interface. And second thing is peripheral interfacing, so we learn it to interface and manage peripheral such as sensors, motors, and display. Then you'll understand the importance of hardware and software interaction, right? Then last one is RTOS concept. So in RTOS concept, like you will gain basic understanding of real-time operating system. RTOS means real-time operating system concept, and you learn how to managing tasks, scheduling, then priorities, and resource allocation in embedded system, right? Then what will be the course outline? So in week one will be like introduction to embedded system and the microcontroller. So in week one, I think all of you watched the lecture. So this week, like is basically basic. So this week define like what is the embedded system, understand the difference between microcontroller, microprocessor. I will that explore various type of microcontroller families. Then we'll focus on the STM30 family, STM32 family, like in the week 2 week, like when we are going deep into the course, we'll mostly focus on the STM32 family, right? Then week 2 is their basic of embedded C programming. So in the second week, we'll like dive into the fundamental of C programming, then especially for embedded system. Then whatever the we'll cover the essential like basic essential concept like data types, control structure, and function. And we'll discuss the memory management and IO operation also. Right? Basically, it will be like it will be useful for the higher week. When you will go to week 3, week 4, week 2 will be using, right? Then that week 3 it is intermediate STM32 programming and architecture, right? So this week we'll delve into the specification of STM32 programming. We'll start the basic general purpose input output GPIO, and which is essential for interfacing with hardware component. We'll introduce the STM32 clock system, basic serial communication using UART, and time management using timer, right? And then we'll touch the ADC like analog to digital converter, which are vital for reading analog inputs, right? Then week 4, so week 4 will be like advanced peripheral interfacing, right? So in week 4 is all about the advanced peripheral interfacing, like we'll explore more sophisticated GPIO features and dive into SPI and I2C communication protocol. You'll learn about the pulse with modulation and actuator control using timer for input capturing. Additionally, you'll integrate various sensors, enhancing our system capabilities to interact with the physical world, right? Then the week 5 it's a digital communication protocol. So this week we'll take deep into the digital communication process. We'll revisit URT, then SPI and ITC, providing like more in-depth coverage and practical application. Additionally, introduce scan protocol that commonly used in automotive and industrial application. Then we'll understand this protocol to developing robust embedded system, right? Then week 6 is all about advanced peripheral interfacing too, right? So in week 6 we'll build on our previous discussion like on peripheral interfacing. We'll focus on the integrating both digital and analog sensor, which are crucial for creating responsive system, right? We'll also cover the basic of wireless communication and discuss power management technique to ensure our system like both effective and efficient. Week 7 will all about the embedded software design pattern and the system architecture. In this week, we will shift our focus to software design. We'll introduce various software architecture and common design pattern used in embedded system. We'll learn about event-driven programming, which is critical for handling real-time events. We'll also cover the error handling and debugging technique to ensure your code is reliable and maintainable. Week 8 it's all about the practice and problem solving. So week 8 is dedicated for hands-on practice. So we'll work on exercise and challenging design to like reinforce the concept we have covered so far, right? Week 9 will introduce introduction to real time operating system RTOS. So in week 9 we'll introduce the real time operating system, that RTOS concept. We'll cover the basic feature of RTOS and demonstrate how to integrate RTOS and STM32 project. We'll learn about the synchronization mechanism, timing, then scheduling, which is essential for real-time application, right? And week 10, advanced embedded C concept. So this week, we'll delve into the advanced C programming concept for embedded system. We'll cover the advanced memory management technique, low-level device access, and eff- efficient data handling. Additionally, we'll discuss optimization strategies for real-time performance and advanced debugging technique to enhance your like development process. Week 11, so development tool for debugging techniques. So in week 11 we'll expose the various development tools available for embedded system. We'll discuss version control system, which are like crucial for managing your code base. We'll also cover advanced debugging technique, statistic code analysis and automatic testing like CI, that continuous integration practice to improve your code quality and development efficiency. Week 12, that is safety, ethics, and professional practice. In our final week, we'll discuss the broader aspect of working in the embedded system field. We'll cover ethical consideration and safety standards, our systems and safe and reliable. We also touch security fundamental to protect our system from vulnerabilities. Finally, like we'll discuss professional development emerging into the embedded system, right? So and that we'll cover that for reference. You can take a screenshot. So basically, for textbook, we'll like we'll cover the like we'll mostly like all the topics are taken from this textbook and reference books. So making first is making embedded system like design pattern for great software by Ilika White. Then second one is programming embedded system C and C++ by Mitchell Barr. And for the reference book, we are referring embedded system fundamental with ARM Cortex M-based microcontroller, a practical approach by Alexander Gideon. And second one is the definitive guide to ARM Cortex M3 Cortex M4 processors by Joseph Pugh. So mostly like these are the like approx overview, like approx content of like for embedded C programming. So maybe little bit up and down maybe happen. Okay, so any doubt in the syllabus and anything you can ask? Any doubt? Yeah, Levin is John. Levin, you can introduce yourself. Levin was,
Yeah, yeah.
yeah,
Hi everyone. I am Livin. I'm also the course instructor for this course.
yeah.
Anything else?
No, yeah. Okay. And any question in the course content or anything? Okay.
Sir,
Yeah.
can you tell one book which will be best for following?
So right now we cannot say this book or this book like maybe you can download all the things while like going to the lectures, or maybe you can in the live session we can like we'll tell for this week this book is better, or for this content this week is this book is better. So right now we cannot say which book is better. So maybe you can download all the PDF. So while going through the courses, you can like after that we can tell that which book is better. Yes.
So, sir, textbooks are mandatory to go through, and references are optional.
It's like a kind of optional. So maybe like whatever the in the lectures cover or in the live session covered, these are sufficient.
Sir, I'm still unable to access the course content.
Why?
I don't know. I have filled the form and paid the fees, but still it is not visible on my dashboard. Other three courses are visible,
I'm
but
also.
embedded C programming is not
Maybe
there.
maybe you can mail to course support team. Maybe I'll
Uh,
note down your email ID also. Maybe you can
Mm.
chat in. You
I
can
I I have mailed to support. Yes.
okay. Okay. Maybe you can like write your email ID in the that G chat. Maybe I'll note down that email ID and maybe I'll talk to upstream. That will be good.
Okay, sir. I am writing my email ID.
Yeah.
Sir, actually, for those who have taken the course through G form, it was not enough. I mean, they haven't got the access to it.
Okay. Maybe then we'll talk to upstream. That will be good. Maybe write down your email ID. Whoever did not got access. Okay.
Yeah, actually, they are just doing this process. So, in last week, actually, this degree distribution program is happened in the IIT. So, they are little bit delayed actually. So, they will just complete this process very soon. Okay, so in maybe 1 or 2 days. Just wait.
Okay. Okay. Just I'm noting down your email ID. Okay. Okay. So maybe we'll discuss the. Okay. Okay, great. Okay, maybe we'll discuss the practice assignment question. That will be good. Okay, so my screen is visible, right? Hello.
Yes, sir. It's
Yeah.
visible.
Okay, so first question is, which of the following reason for designing the microcontroller instead of like MC instead of using microprocessor? So you have to choose the reason for designing the like microcontroller instead of microprocessor, right? So first option is to achieve higher computational power. Second option is to minimize power consumption and extend battery life. And third option is to accommodate larger on-chip memory capacity. And fourth option is to simplify the design for general computing tasks. So right option is to minimize power consumption and extend battery. So if you saw the lecture and slide also, so let's see. So you can see that requirement of embedded system. So you can see, so to minimize the power consumption and extended battery life. So you can see that requirement like yeah. So it's for to minimize the power consumption and the like and extend. So basically that microcontroller are designed for the focus on the energy efficiency like and power consumption long battery life. Okay, so first correct option is option B. And second question is, what type of application are typically targeted by Texas Instrument MSP 430 microcontroller family, right? So first is high performance computing, second one is ultra for application, third one is communication intensive application, and fourth option is general purpose computing, right? So it's like for MSP32, it's like it's targeted for ultra power application. So if you see that slide MSP32, so you can see that it's ultra low for application focus. So for MC family like MSP 430 designed for the ultra low for application, right? So correct option is B. And which programming language is third question is, which programming language is commonly used for the low level embedded C or low level embedded system programming and is known for its efficiency and direct hardware access. So options given are Python, C, Java, and Ruby, right? So you know that like for like for embedded system programming, we are mostly used C, right? So correct option is C. Python is like high level language, Java also like high level language. Okay. So anyone like why you are using like C as like embedded C, like C like embedded system programming?
Mm,
Not Python, not Java.
So it takes less memory.
Yeah, so and it's like also close to hardware access, like, and its ability to handle low power programming tasks effectively, right? Yeah. And fourth question is, which of the following not a typical application of a embedded system, right? So you have to find the which of the following of plus application not a which of the following not a typical application of a embedded system. So first one is industrial control system. So this is a like this is a
yes, sir.
yeah, this is a embedded system. This is an also like embedded system. Then consumer electronic, this also like fitness band TV, this is also embedded system. This is medical device, so this is also like embedded system, right? Enterprise server, I think this is a not a embedded system, right?
No, sir.
Yeah, and tablets, for tablet like generally like it's general purpose uses like tablet also not a embedded system, right?
No, sir.
Yeah, so these are the two correct option. Question number 5, which of the following statement best describe microcontroller? So you have to choose the which of the following statement describe the microcontroller. So first one is a complex computer designed for a general purpose task. So this is, I think, not a microcontroller. This is not a correct option. Second one is a self-contained computer on a single chip with the limited resource. I think this is the correct option. Third one is a high performance processor used in server and orchestration. This is, I think, that microprocessor and a specialized circuit for performing analog to digital conversion. This is also not a correct option. So a microcontroller says, like, second option is the correct option. Everyone got it?
Yes, sir.
Now question number 6. When choosing a microcontroller for a project, what are the some important factor to consider, right? So when you are choosing the microcontroller for a project, so what are the important factor you have to consider, right? So first option is processing power and memory capacity for your application. So you have to consider processing power and the memory capacity, right? And the second is availability of compatible development tools and libraries. So you have to also consider the what are the compatibly available, then tools, library, all the things. And third one is the power consumption and operating voltage. So that we have to also check that power consumption, like low power, high power, all the things, right? And how like it's operated, which voltage is operated, you have to also check. So basically, like, you have to check all the things, right? So it should be all the above. So question number 6 is any issue or any doubt?
No, sir.
Okay. And question number 7, a device that would likely benefit from a microcontroller is a device that would likely benefit from a microcontroller. So you have to tell, like, which device will benefit from a microcontroller. So desktop computer is already a computer, right? And it's medical device. So it's, yeah, medical device monitor, like a glucose, like glucose meter, like to meter, like measure the glucose meter, to heart rate monitors. These are the uses. So this is a medical device. This is the correct option. That web server is not used, and high performance graphics card is also not used. Question 7 is correct option is option B. Now question number 8. Microcontroller families are categorized based on the various factors. So which of the following not a typical classification criteria? So you have to do that, like, microcontroller, like, it's categorized on the various factors, right? So we are not, which of the following not a typical classification criteria. So now, like, what size we also, like, it's 8-bit, 16, we are taking consideration, right? And in instruction set architecture, we also check that which it's architecture, like DX6, right? Now manufacturer, like, we also checking, like, which manufacturer is, like, PIC 432, it's a ESP32, we are checking, right? Operating system compatibility. So we are not checking the operating system compatibility, like which support like operating system, right? So this is not a typical classification problem, right? Any doubt in the question number 8?
No, sir.
Okay.
Sir, why?
Yeah.
Sir, why is operating system not a distinction? Like operating system does differ in functionality.
For like, see that microcontroller, we are only this, we are not checking that it support Windows or Linux, right? Then it will be general purpose, right? Not a kind of that, right?
But
Then-
actually, by the end of the day, we are not going to load any operating system into the microcontroller. Right?
Yeah,
We're only
correct.
going to compile the program.
Yeah, correct. Yeah. Then question number 9, why is low power consumption importance in embedded system? So why, like, low power consumption in important in the embedded system? To increase the processing system, to reduce the heat generation, to extend battery life, both B and C. So for power consumption, you have to reduce the heat generation also, and to extend the battery life also. So correct option will be both B and C, right? Question number 10, which of the following reason microcontroller are often preferably over microprocessor in application? So you have to choose which of the following reason controller prefer over microprocessor. So first is high processing power. It's not correct because microprocessor are high processing power. Low power consumption. This is correct. Low power it's like taking low power. Complex operating system is not correct, and extensible graphical user interface. This is also not correct. So correct option will be option B. So you can check also like that feedback is given, right? So you can also read the like solution, and if you did not understand, you can read the solution. Okay, so any doubt in the practice assignment question?
No, sir.
Okay, so any doubt in the week 1?
Sir, just a general query.
Yeah.
So, what sort of like to learn Linux, we need to do a lot of practice.
Okay, can you repeat? I did not got.
Like, I mean, for each of the subject, like when we came to C, it was very new, so we struggled a lot. And when it
Yeah.
came for Linux, so same thing, but we became much familiar with the programming languages because we have already practiced C. So a little bit of practice helped us with Linux.
Yes.
So how will it be with the embedded C?
For embedded C, like you have to like that prerequisite is C and Linux, right? So you have to know like well C also and Linux also, and it will be like moderate practice. It will like you can easily score like high score like, and just like join the live session. Every live session will provide all the like material, and we'll also discuss some problem. So I'd suggest like join live session, and whatever the lectures is there, like practice all the practice like programming assignment question and graded assignment question. This will be sufficient for you.
Okay, so and what microcontroller they will be using?
Like I think now STM32 we are using.
Okay.
Yeah.
So do we need to buy it?
No, we'll be using simulator. So don't worry, like in the live session we'll discuss all the things which simulator we'll be using. We'll also like provide support, so don't worry.
Okay, so thank you.
Yeah. Okay, so any doubt? If you don't have any doubt, then we'll make close the session.
Here, Subindu, I think many of the students have not received the access of the course. So I think so after getting the access, so maybe they can come in the next session, and
Yes.
then we can discuss the things. Okay.
Yeah.
So this is the one request to everyone: just watch all the lecture first before joining the live session, and collect your doubts and then ask your doubt in the live session. Okay. So that will be helpful for you also.
Yes. So maybe today we'll talk to upstream, like maybe.
Yeah, we will report to the ops team that many of the students have not received the
Yeah,
access.
if possible, today we'll give the access, and maybe tomorrow live session you can join and you can ask your doubt.
Yeah, so week one is basically theoretical concept about the this embedded system. Nothing is no very tough. Okay, so after just watching the lecture, you will get all the things regarding the assignment solution. But from week two onwards, that we will start this little bit programming. We will start from the C basics. Okay, so what are the basic important things required for the embedded C? So that we will revisit little bit in the week two, and after that we will also discuss about the microcontroller, which microcontroller we will use, which online simulator we will use. Okay, so that we will discuss, yeah, in detail. Okay, so yeah,
Yeah,
Levin, yes.
so shall I show some demo on this simulator so that people like get familiar with the simulator?
Levin, so I think
Levin, can
tomorrow
you
is also there one session.
yeah, maybe you can show tomorrow. That will be good.
Okay.
Yeah.
Okay.
Sir, at least what's the name of the simulator? Because I got the course access.
So it's WOKWI. It's called WOKWI. WOKWI. You can search that like WOKWI simulator. It's available online.
Yes.
Pasted the link of that website there.
Okay. Thank you, sir.
Sir, will we have separate lab session or it will be in live session only?
It will be in live session.
Okay, sir.
Oh,
Okay, thanks for joining the session. So we'll meet you tomorrow. Thanks for joining. Thank you, everyone.
Thank you, sir.
Yeah.